Okay, for people joining our live stream, we are in the late stages of finishing documentation and other things for our new synthetic geometry capabilities for version 12 of Wolfram Language. So the first thing we were looking at is geometric scene. And I think we need to look at this documentation page and we need to see all the things it does. Boy, why are we saying it that way? I mean, if it's represent, I think this is not a great example. Oh, you haven't really got many examples, or do you have examples here? But you got to explain this business about how this generates a scene that has literal ABCs in it, right?
Okay.
What do you mean by little?
Well, I don't know. What is this thing? This thing,
like, have an example showing the input form.
Well, yeah, I mean, that particular thing, now if I say input form of that, it will have literalized this ABC. So what I would do here is to say, the first example here, I would say geometric scene of, A arrow, 1, 0, B arrow, I don't know, tell me a triangle. Actually, I would like to say 0, 0, B arrow,
1, 0, and C 0, 1.
Okay. And now I don't know why that brace is there. Is that brace needed?
Yes, it is.
Oh, sorry. Yeah.
Should
sorry.
it?
List of the hypotheses are in list form.
Okay. So there. Okay. So this would be, represent a geometric scene with explicit coordinates for points. Okay. And now I think what we want to say would be something like okay, here we'll say a geometric scene, a symbolic geometric scene. This is a symbolic geometric scene. Actually, it'd be nice to put some constraint in there. I don't know.
You can do
representing a triangle with interior angle. What's the angle?
So say planar angle of list ABC.
Well, I would do
equals.
Yeah, say something. Yeah.
We use planar angle. We just also polygon angle.
Equals. Okay, that's fine. 30 degrees.
Well, yeah. Okay, let's say equals 30 degrees. Why not? Actually, let's do it the other way around. Okay, so a geometric. This represents a symbolic geometric scene. This of a triangle with angle 30 degrees. Okay. Random instance fills in explicit. Well, okay. No, why don't we say triangle with points? This represents a symbolic geometric scene containing a triangle Filled in explicit coordinates for the points.
Can we say finds explicit coordinates for the points?
I wouldn't, because that's not what we're talking about here.
Right.
What we're talking about here is geometric scene.
Right, and also it returns the geometric scene itself with the coordinates filled in. So, yeah, Stephen's right.
I don't know whether we want to do the input form. I mean, you should do the input form further down. Is there anything you can do now to sort of show that it is okay? Let's say conclusions there or something. Can we do that?
There are no conclusions for that.
Okay.
We could do hypotheses.
Well, let's do points here.
I think that there's a bug in this version. It's been. Oh wait. Yeah, there's a bug in this version where points just returns all the variables. It's been.
What's wrong with this? I mean, this looks more or less right here.
It also has the empty list for the.
No, I understand that.
Yeah.
Okay. Fills in explicit. This finds the rules giving. This gets the rules corresponding to the points. Gets the rules. Giving coordinates for the points. Okay, let's go back up here. I mean, this may not be perfect, but this is my attempt here. Okay, so let's go back up to the top. Okay, represents a 2D geometric scene with points involving points P, involving points P sub I, and no, geometric scene. I'm going so defined by hypotheses in terms of the points. How about that? In terms of the points P sub I.
Sounds good.
Okay, so now what's this numerical quantities? What does that mean?
Right, those are scalars. I'm not necessarily sure we should put numerical there because they're still symbolic. I would probably put just scalar
values.
Yeah.
Represents a scene whose hypotheses depend on the scalar values K sub I. Okay, represents okay, wait a minute. Represents a class of 2D geometric scenes. Is that right here? Because this says a particular instance. So
if there are rules for everything, then it should be a particular instance.
No, I understand that. But what do we say about this one? If this one isn't an instance, what is this one?
We had actually this discussion earlier today, and it's not clear if this viewpoint of this class is a sensible one.
I don't think it is. Actually, I think we should change the way this is said here.
Like, it's more abstract versus concrete.
Okay. Represents a two defined by in terms of the symbolic points P sub I.
Do you want to say represents an abstract 2D geometric scene, and then?
Yeah, it's not a bad idea. Yeah. Abstract 2D geometric scene defined by the hypothesis. I mean, hypothesis is a weird term when you've got a triangle sitting there.
It's the existence that you postulate. Yeah, because
nice philosophical recovery, Michael.
No, because the geometric scene might be empty. It might not exist.
I see what you're saying. Represents an abstract 2D geometric scene. Defined by involving the symbolic points and defined by the hypotheses. Does that seem reasonable? Involving.
I like another one better. In terms was good, so it's pretty clear what you can put in HIP.
Okay, defined by the hypotheses. Okay, represents a scene whose hypotheses depend on the scalar and the symbolic scalar values K sub I. Okay, represents a specific instance of the specific instance of a geometric scene with particular coordinates for each point. Is that reasonable?
Particular might be misread, but because particular, I feel like has many flavors of meaning.
Okay. With definite coordinates, with explicit coordinates.
Explicit numeric or something like this.
Okay. Represents multiple specific instances of a scene. Represents a collection of specific instances. Represents a scene from which the conclusions con sub I have been derived or can be derived.
No, because you can put any junk in, if true or not.
Okay. Well, so what's the point of this one?
Well, it's the fine geometric conjectures code makes conjectures which are probably true, but maybe not true in general. But when that returns a value, it returns a geometric scene with the conjectures in that last argument.
Or the user might want to put some in that seems sensible to the user manually.
Okay, represents a scene together with some conclusions about it. Okay. 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 No, this isn't right. It's not a diagram. Right? It really isn't a diagram. It's displayed. What we want to say, a geometric scene object with...
I think what you're writing is already down there, further down. Geometric scene instance is displayed in standard form and traditional form.
Where?
No, too far.
Just 2-3 lines.
Yeah. A geometric scene instance is displayed in standard form and traditional form as a graphical image. Start with that.
I don't believe in that one. Let's try writing it again. I mean, somewhat similar, okay? A geometric scene object with explicit values for the coordinates of points. The explicit values for all points and scalars for with explicit coordinates and values is displayed as a graphical diagram. We can say is normally displayed as a graphical diagram. How do you feel about that?
I think your use of the word diagram is a little bit different than the use of the word diagram in our original first one, because we don't use typically the word diagram for our graphics.
I know, but this I call a diagram because it's got these weird blue points and things, and it's got all kinds of angle markers and so on. That's why I'm calling it a diagram. I mean, this is a new class of graphic. It's a diagram, right? And I mean, for example, we should make sure that in the keywords here that we have the word diagram, I think should be in there. Construction, Euclid, certainly geometric construction should be in there. Anyway, okay, all right. So let's keep going down here. That includes explicit. No, with is better because all of them have to be filled in.
Yeah, I was about to say you should say something about all.
Okay.
With explicit coordinates and values for all points and scalars.
With explicit coordinates for all points.
Yeah.
And explicit values for all scalars. Is normally displayed as a graphical diagram. Okay. Now, we got to say what can be in the hypotheses, in my opinion. I think this comes much lower. First, we have to say the hypotheses, the hypotheses in the scene can contain well, we're going to basically give this big long list, right?
Yeah.
Basically, objects and relations.
Okay. The hypothesis in the scene can contain specifications for objects, indicating that those objects can exist, indicating that those objects exist, as well as relations and assertions. About measurements on those objects. Is that correct?
Not necessarily.
Yeah.
Okay.
I just leave it relations and assertions.
Okay. The hypotheses in the scene can contain specifications for objects. Well, can assert that certain objects exist, as well as give relations and assertions about those objects. Okay. The following primitives can be used to indicate that particular objects exist. Now, it's this thing here, basically, right?
I think explicitly bringing up this existence thing is kind of esoteric.
Why? It's very confusing otherwise. Everything else is a statement.
Right, and also, I mean, Ian, the existence of, say, a simple polygon, in the context of all these other hypotheses is not trivial.
By the way, why isn't regular polygon in that list at the beginning there? Why doesn't that contain regular polygon?
It's supported.
Okay. I think this is in the wrong order. Okay. I think it's in way the wrong order, this thing here. I mean, I would go from, why isn't this going from?
I think it's in alphabetical order.
Oh, for goodness sake, that's wrong. That's crazy wrong. Okay.
We can reorder it.
Yeah. So one other thing maybe we want to mention in here is, for instance, polygon inside of geometric scene includes the assertion that it's a simple polygon.
Oh, well, then why don't we say that? Why don't we say simple polygon?
And also, so I think line segment. So outside of geometric scene, line segment or line gives a multi-line. Inside of geometric scene, it's still a straight line. I'm not sure if that's explicit in line segment, but I think
we should say straight line. How many points can it have?
Any number.
I think alphabetical order is the correct thing.
Why?
For example, look at graphics.
No, but that's a different thing. I mean, this has much more structure, I think. Oh, maybe it doesn't. I don't know. All right, okay, fair enough. Okay, straight line. Okay, so then we've got then here we've got regular polygon. What is that form?
There's a lot of optional arguments.
Basic form was just n.
Yeah, n for.
And then, but it's got to give some points, doesn't it?
Right.
I excluded it because it doesn't really fit in very well with everything else.
Well, why not?
Because it's going to put it at a particular coordinates. They're all supposed to be like coordinates.
Well, how do you establish? How do you say that something is a regular polygon?
Geometric assertion.
Okay,
right.
Fine. Okay. Let's loop back to this just a second. Okay, the hypotheses in a scene. When an object is given in the hypotheses for a scene, no.
When an object appears as a hypothesis in a scene, it assumes the existence.
Yeah, I understand what you're saying, but I think it's just utterly obscure. It's a hack. I mean, hypotheses in a scene can assert that certain objects exist, as well as give relations and other assertions about those objects. The following primitives can be used to indicate that particular objects exist in a scene. Okay? And now we need to say the points PTI that as well as parameters such as R, the points PTI and parameter can be Okay, so we don't even say here that that they can be. Okay, let's say this in geometric scene of P1, P2, ... The P sub I can be symbols or any other type of expression.
Actually, the most common one would be probably strings.
Can be strings, symbols, or any other type of expression.
That's of course not 100% correct. Yeah.
What do you mean?
It cannot be two. Two is the expression. It will not work.
Okay, can be strings, symbols, or
any non-system expression.
Or other symbolic expressions.
Yeah.
Functions such as random instance fill in specific values for the P sub I, satisfying
and K sub I.
In such a way as to satisfy in such a way as to satisfy the hypotheses. Ali in our live stream is asking, can you fit a circle through n real points using circle through and find its radius? What's the answer?
We drop the radius function, but implicitly you can use you can give a symbolic center and a symbolic radius as optional second and third arguments.
And then what?
Are we inside or outside of geometric scene?
Well, let's say outside.
This is Charles's territory then.
So this is the thing, and then what do we do here? We want to find out. So again,
it would evaluate to circle of center comma radius.
I mean, if you open the documentation, it's described.
Wait, what did I do wrong? What did I do wrong here?
I didn't yet committed the code, so you will come back and evaluate it.
Oh, okay, but this will turn into. So this will do exactly what Ali wants it to do.
Yes.
Or it's roughly equivalent to sequencier. It will give you exactly that if you apply right now sequencier on it. Plus or minus the head.
Okay, that's super cool. What do you mean minus the head? Why minus the head?
It'll be a circle.
We are going to return a circle. Here we are using sphere in 3D.
Yeah, right. Oh, I see. This one should return circle rather than it should simplify the head.
Yes.
Okay. Yeah. Now what happens if I give it a point that doesn't lie on that circle? Should be a list of 3 affinely independent points. Come now.
We will fix that.
Okay, very good.
How can you fix this?
No, the message.
Oh.
We're not going to fix the mathematics. In such a way as, okay, fill in specific values in such a way, I don't think it wants the comma there. Okay, the hypothesis in a scene can assert that certain objects exist. Okay, why don't we put it the other way around? It can give relations and assertions about objects in the scene. Well, actually, can give actually no. Okay, wait a minute. Can list objects that must appear in the scene and can give relations and assertions about those objects. How about that? That makes
I like that so much better. It's not even funny.
Okay, good. The found to indicate the particular objects. Well, we can actually use the same words. Appear in a scene, exist in a scene, appear. We can say exist. I don't think it hurts anything there. Okay, the points PTI.
I mean, but not every time that you're using those primitives are you going to be using it to assert they exist. You might be using it inside an assertion or inside a relation.
I see.
You're just using them.
I see. Okay, the following primitives to be indicate to objects in a scene. Can be used to. The following primitives can be used to represent geometric objects. To represent geometric objects. Any problem with that?
Fine.
Okay.
So, Ian, do you have like regular polygon, rectangle, and parallelogram listed elsewhere?
No, they're completely undocumented.
Sorry, say that again. What?
The regular polygon, parallelogram, and rectangle should be supported, but are I think currently undocumented.
Well, so put them in. I mean, you want? I mean,
this is what I was saying earlier. Is they those things take stuff like vectors and put things in particular areas.
Well, rectangle certainly exists.
Yeah.
So yeah, that's actually a question. I currently support, say, rectangle of a list of points, which doesn't match any documented.
That's no good.
Okay.
So, I mean, listen. For Charles's purposes, I don't even know what Charles does for in parallelogram, but I mean, you know, parallelogram could have two lives. One that's based on explicit coordinate lists that has one form that uses the vector representation. This is a bit horrifying. And the other that's based on points.
Okay. Yeah.
Is that plausible or is that hopeless?
As long as the argument structure is syntactically different, there shouldn't be a problem.
On my local version of the scene jar, I actually support it.
I don't personally see much value in it, considering that we have geometric assertion. You can assert that something's a parallelogram. Where do we stop with this? Do we also add trapezoid, kite,
I would think so.
rhombus?
Yeah, why not? I mean, because that way you can say, I mean, in the statement of a geometric, you know, in making a geometric statement, you will have and the rhombus ABCD blah blah blah. And I don't see why we shouldn't have that. And I think it's consistent with this to have parallelogram. I mean, right now you have parallelogram.
But right now we have a situation where generic values represent existing objects. If we have this overdetermined things from the name and we have still the same number of arguments, generically they don't exist anymore.
What are you talking about? Wait a second, I don't understand that. If you've got a polygon, a triangle, let's say, with ABC. So what I'm imagining is that it's parallelogram ABCD.
But then for generic realizations of ABCD, this object doesn't exist.
Right. It's kind of like circle through.
For triangle, you can use any 3 points, they form a triangle, but not any 4 points form a parallelogram.
Right.
It's a good point. It's a good point.
But it's a low-dimensional subset that only exists.
I understand that. All right. But all of these have the property
But it's more a matter of how you are going to use it, right? The same as polygon, right? You give point P1, P2, P3. You assume they're samples, right? So the same apply for parallelogram. It's just that we have a specific syntax there, P, comma, the vector. I mean, there's no issue of extending it.
But typically, we don't use argument structures where some arguments can be derived from the rest.
Well, but for us, it's more a matter of detecting that is a valid. As long as it's not a valid region, we don't do anything with that. And in geometrics, we just have to interpret it.
But Michael's point is that the 4-argument parallelogram, this point here doesn't even need to be stated.
It's the same as a circle true, right? Where essentially you need 3 points.
If you have extra points, if you give extra points,
yes,
circle through.
So if the point is not valid, we come back on evaluation.
Okay, fair enough. So what your point is that parallelogram could work with 3 points. I don't know which 3 points. I guess the 3 points.
Like the one corner and the 2 that represent the corresponding vectors.
I see. So then the form is, the alternative form is parallelogram of list PT1, 2, 3, comma, dot. Well, the dot it can only have one more. So then we probably want to do the same thing with regular polygon, right? We could have a regular polygon form. Go ahead.
Would this be a primitive?
What do you mean by that?
Would there be evaluation of it? Because this is a big difference between circle through. Circle through evaluates to a circle, whereas parallelogram just stays parallelogram.
I mean,
go ahead.
Per se doesn't really per se matter for when you're outside the geometric scene, right? Or some primitive, we just detect that they are valid and we flag them. So it's consider them as base primitive. So evaluate or not, it doesn't change much.
I think it's nice to have this capability, to have parallelogram, to be able to say, because you're translating. I mean, we haven't really. Okay, here's a question, guys. How much of Euclid have we been able to translate? How much of Euclid have we bothered to translate so far into this stuff?
We've never tried to just translate Euclid.
I think we should get somebody to do that. I think it'd be a great project for some studenty type. I mean, some, even high school student who's studying geometry, it would be a great project to try and just translate Euclid, jump 2,000 years, a little bit more than that for Euclid, and translate it into this form. I mean, it should work, right? Every proposition in Euclid, well, at least all the geometric ones should be translatable, correct?
The 2D ones?
Yeah, I think so.
Good point. Yeah. Okay. So if I pick a random one, if I pick a Euclid, I think I even have a copy of Euclid on my shelf here. Let's see. Oh, yeah, so I do. All right, I'm going to pick a random page. Oh, boy, this is in Greek. Schemata, Grammar, Estita, Hupa. I think I might even be able to translate this. Wow. All that education might be useful. Wow. I can more or less get that. Okay, but anyway, it says these are a bunch of definitions. Wait. That was a bunch of notes, and that was silly. This book is full of notes. Okay, here we go. Here's the actual propositions. Boy, he has the geometric solution of a quadratic equation. I didn't know he had that. Okay, this is probably not a good use of our time. I don't even know. I don't think Euclid had his. I mean, I'm pretty sure the original Euclid documents, at least as they've survived, don't have the proofs. But anyway, all right. So, oh boy, these are complicated. Proposition: to cut a given straight line so that the rectangle contained by the whole and one of the segments is equal to the square on the remaining segment. I don't understand that. I mean, that means that's a construction, right?
Right.
Now, how do we do something like that? What does it even mean to do that?
We're not really representing constructions right now.
What will we need to do in order to represent constructions?
Well, we
Think about it long and hard.
No, but I mean, isn't
Geometric
that
construction head maybe?
No, but I don't understand that. Why isn't it the same thing? Because we're going to have a random instance again.
I mean, I think Ian's talking about compass and straight edge constructions.
Well, I understand, but I think this is a construction like that as well. I'm not sure.
Well, it becomes easier if we allow compasses, straight edges, and computers.
I think the main part is similar to this discussion we had about the option saying that some points are free, that we have to go strictly forward. Like we cannot randomly have non-local points.
A construction is an ordered sequence of steps where at each step you introduce a new point that wasn't previous in any of the wasn't present in any of the previous steps.
So in other words, what you're saying is, to a geometric scene, there should be an operation you can perform that basically says, stick the compass, twirl the compass around and put it down at this place or something.
Well,
in order to be able to do Euclid stuff, yeah.
Right. But in order to do a construction, that is to represent, but then I see. But then we have to represent a series of steps in the construction.
It would be kind of two-step. First, it would be similar like you get a Lex order of a Gröbner basis, so that each new equation has only one variable more. Mm-hmm. In addition, you would need a connector between each two lines.
Okay. But so I'm just trying to check that our representation here isn't going to fall apart if we have to deal with constructions.
It must definitely be extended.
Yeah, but is it going to fail? I mean, what is the relationship between geometric scene and what you need for a construction?
Geometric scene is the very end of the construction.
I see. So you're claiming that the assertions. What are you claiming? Are you claiming that there are assertions, or there must be assertions? Because you say...
I think you rewrite the assertion. You rewrite the assertion in such a way that with each new assertion, you only use things you had earlier.
Okay. But so, look, I mean, there are things like, given a regular pentagon, pick... put your compass on one of the points of the pentagon, draw a circle that goes around another, point in the pentagon, and then put a line between this and that. That's the type of thing you're doing.
I think a construction would probably be a sequence of geometric scenes. At each step, you would have a geometric scene, and then you would have a process that would tell you how to get from one to the next one.
Where the geometric scenes... But then you have to, how would that work with variable scoping? Because what you're saying is you'd start off with a symbolic set of things, and then you would be adding, at each step, you would add essentially a somewhat arbitrary, but with an assertion. Yeah, I mean, like if you say with a compass, do this, it would say, the distance between that and that is equal to this.
You could probably still have, say, a geometric scene head, but rather having in the second argument right now a list or something like this, we could have an association which is the steps. And we wouldn't have a problem with the variable names.
Yeah, I understand. So what would that look like, Michael? I mean, so we'd say geometric scene, and then we'd start saying association, step 1. Then what?
I was more thinking like result of step 1 is scene 1, result of step 2 is scene 2.
I see. Okay. Interesting. I mean, it's not completely obvious to me because that's not describing the construction. That's merely describing the results of the construction. boy, it's disappointing that after 20, how long is it? 200 years or something, that we still can't completely nail, a computable version of Euclid.
But on the other side, like if you think only with the recent function of adding something to both sides to equation, we can do some simple rewriting of an equation programmatically. Even this is only very new.
Well, I understand that. But I mean, so what's your point? That that's new, or that's? I mean, to what extent is that like the stuff that you would do in the Euclidean case, in the Euclid construction type case?
You take something that you have, a equal b plus 2, and you do something to it to get something new.
Right. But so basically what you're saying is you take a geometric scene and you do something to it to get a new one.
Right.
Fair enough. Okay. All right. Let's keep going here. Okay. The points P sub I can be symbolic. The points and parameters in geometric objects, the points and parameters can be symbolic or can have, and parameters can be symbolic or can have explicit values.
Are you rewriting your second line from above?
No, I'm writing it about this.
Ah.
Can be symbolic or can have explicit values. Correct?
Mm-hmm.
I mean, it could be a circle of radius 1 or something.
Yeah.
Okay. Next. Okay. Now you've told me these are constructions, but I don't entirely buy that now.
They're the results of constructions.
Okay, let's just pick up all this stuff here.
The term construction is overloaded in mathematics.
Okay.
But I feel like they show nicely the point that there are various points that go in and you get the new object out.
Yeah, okay. Okay, the following primitives can be used to the following constructions on geometric objects. The following can be used to represent constructions applied to geometric objects. Is that reasonable?
Sure. Do you want to actually mention on the right-hand side what sort of primitive it actually is? Like an angle bisector is an infinite line?
Yes, angle bisector as an infinite line. Midpoint. That's a point. It's really obvious. Perpendicular bisector as a what?
Infinite line.
Region centroid as a point. Region point nearest to region. Yeah. Is that right? Point
yes.
on a. No, it isn't. It point in a region nearest.
Oh, that's right. You're right.
Point nearest point in a region. What is triangle construct?
It's kind of a wild card.
Yeah, okay. 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 The following assertions about geometric objects and their properties can be given. This should say a point is in a region. I think here we should just say values are numerically equal.
It might not be numbers.
Like a line is not a value.
Right.
What does it mean with equal?
Well, so you can say let T equals triangle of ABC, and it'll just represent the triangle anywhere in the scene.
I see.
I think just equality probably then.
You should just say a point is in a region equality.
Sure.
Assertion about a geometric object, is that correct?
Assertion or relation. And it could be more than one object.
Is it a named assertion?
Yeah.
Yeah.
Okay. What's this?
That's the same as the element at the top. So I'm also supporting the
Less than, greater than. By the way, that will need to be fixed. That's stylistically wrong. That thing with region member at the top there. Makes sense.
Mm-hmm. Can we use less than and greater?
Yeah. Wait. Quality of values or objects. Yes, absolutely. Less than and greater than work, don't they?
I'm not so sure.
It's a question of implementation, not about.
What are we talking about?
Can you use inequalities in a geometric scene?
Yeah.
Can you use inequations as in not equal to?
No, because find minimum can't handle those.
Okay.
Well, there are ways. If you explicitly say points are distinct, kind of like that inside of geometric assertion, I forget what the string argument is, then it'll handle it. But if you just have a general not equals, it'll return unevaluated.
I think then you wanted to mention the subset.
You're right. So
inequalities between values.
Yeah.
Yes.
Again, that's formatting is not correct there.
So for the top one, we also support lists of points as subsets of regions. If you're using the
element thing,
inert, the subset sign.
Inert subset or subset equal.
Okay.
On the left-hand side.
So you're saying here, if I say, I can say a list of points here.
Right.
And then what? A subset sign or an element sign?
Use subset.
Subset, okay. A set of points are in a region.
Right. Subset equals works too, but
But of course, just to make sure a slippery slope in the sense of this cannot really evaluate because we probably don't want to use subset for this.
Well, wait a minute, isn't there a subset Q? This isn't subset Q, is it?
No, it uses the
It's more or less just reuse the symbol because it's nice,
right.
but there's meaning attached to the symbol.
But there isn't a meaning, is there?
In Mathematica, there's not.
We are attaching the meaning in it
Right.
by putting it in a geometric scene.
That's the point.
Well, that's a big deal. I mean, that means is it subset Q or is it something else? Let's not document this right now.
Okay.
This is something we need to figure out.
That's why I was mentioning it.
Right.
Yeah, we can't really use subset Q though because
I know it'll evaluate
Yeah.
in some weird way. Right.
Well, to false.
Okay. The following assertions about geometric objects and their properties can be used. The following measurements on geometric objects. Okay. 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 Okay, now we have to say okay.
Under the third line, functions such as random instance, we need to have a similar thing for functions such as find geometric conjectures, fill in conclusions.
Is there a reason why we're saying functions in the plural when there's only these two specific functions?
I don't think this one should go in here. I think this should go further down.
Yeah.
We're still trying to. Okay, so next thing we have to say is this thing about the multiple cases, I think. You know what? I have half a mind to say geometric scene gives properties of a geometric, gives the property prop. I think these are always strings, right?
Yeah.
Okay, list of conclusions about the scene. Well, list of conclusions, it may not be about the scene.
I would say graphics object.
Okay,
to emphasize
diagram as a graphics object. Diagram of the scene.
Do the same thing for tab view.
Yeah, okay. List of instances of the scene. list of points. Well, now what does it do if they have, okay, list of points, list of point specifications for the scene. List of scalar value specifications.
Sounds reasonable.
Okay.
Diagram of the scene as a tab view object.
What's that? Say that again.
Diagram of the scene, comma, as a tab view object.
No, it's multiple instances. Yeah.
What's that?
I said it should be diagrams because otherwise I would use a tab view. Tabbed collection of diagrams of scene instances.
That may not be the only kind of tab view. If there's conjectures, you also get a tab view that highlights the conjectures.
Right, but the tab view subvalue I think only works on when we're considering multiple geometric scenes.
And I think that's wrong.
I don't know.
Okay, so what do you think it should do?
We can get a tab view for two different things, having more than one scene instance or for having conjectures that need to be highlighted.
I'm not sure that's right. I'm not sure that's the right way to do it. I'm not sure that second thing should be the same as tabbing through scene instances. Really don't think that should be necessarily the same.
Yeah.
So then how do you visually tell the difference between a scene with conclusions and one that doesn't?
I don't know. What does the scene with conclusions look like?
Tab for the...
It looks like a tab view.
Well, yeah, but for the conclusions, each tab is a list. Each tab is the conclusion. The name of the tab is the particular conclusion. For the just normal geometric scene instance, each name of the tab is just successive integer.
But we could have various versions of the tab view string. That made clear who we're tapping through.
Yeah, I think so. I agree. I don't think this is right. So I'm gonna futurize this for right now, and let's figure out a proposal for that. Let's just try getting through these, and I'm worried that I'm going to run out of time here. Hold on 1 second. Okay.
We come back to the very beginning point. Do we want to spell out that it doesn't have any Horde attribute? So does it fully evaluate its second and first argument? Or do we want it to give it? Because that seemingly, from what I understand from Jose from the IID meeting, there was discussion about this.
Let me avoid that point right now. Okay? Because I think if it doesn't hold its arguments, we can be silent on the matter.
Okay.
Right.
Okay. Okay. So in the form geometric scene of scene 1, scene 2, and scene 3, I don't even understand what that scene 1, scene 2.
That will actually evaluate to a geometric scene where it collects together the points and values in the first argument.
Oh, okay.
And that automatically formats as a tab view.
Is converted to a geometric scene object in which each point or scalar value in which a list of forms is given for each point or scalar value. Is that right?
No.
Looks like it's right. It looks here like it's right.
It's not giving a list for each P1.
I see. In which multiple lists of points and scalar values is given. The resulting construct.
Do we want to put the word explicit somewhere here so that nobody gets confused who is here multiple?
Okay, fine.
Yeah.
Okay, with explicit.
With explicit scene eyes.
Explicit scene instances, scene I.
Do we want to say of the same abstract scene here?
Yeah.
Well, let's say that as a separate sentence.
Okay.
Is converted to a single in which multiple lists of points and scalar values are given. The scene I, well, the resulting.
The original.
No, I'm
scene
saying
I
the
must be
resulting
instances
object.
of the same abstract.
Yeah, I understand. It's converted to it in which. So, okay, it's converted to a object in which multiple lists of values are given, so long as the scene I as long as all the scene I correspond to the same abstract scene.
Do you want to say correspond or are instances of?
Are instances of. Okay.
This
So
formats as a tab view.
I'm going to say that. Yeah, I'm going to say that. Next thing. Geometric scene. When geometric scene represents multiple instances of a scene, it is normally displayed in tabbed form as a tab view object. Okay.
And should that be moved up to the
I don't
top?
think so. No, I absolutely don't think so. I think it's super confusing.
Okay.
Okay, what's this down here?
Style.
Right now, not all possible sugar works.
Okay. Okay. the display of constructs of geometric objects can be specified using style. Style information, style specifications do not affect the geometric meaning. Is that right?
Correct.
Okay. Whoops, that was wrong. Pressed the wrong button.
Is it normal to say for geometric scene when you're talking about the options?
It is when you've had this long and ponderous a discussion. That's an apparent sub-option. Oh my God, what a mess. Why isn't that an association?
This is patterned off of method sub-options.
I think it should be an association.
But we don't do this frequently.
All right, okay. Well, because we didn't have associations when we first started working.
That's correct, yes.
Can be provided
That should be the standard wording.
Well, I don't know. Well, I hate it. Any option of graphics can be given. Functions such as find geometric conjectures fill in conclusions in geometric scene objects. Okay, hold on one second. Okay.
Should that bit about conjectures be up higher?
No, it should not, because this is confusing enough as it is, right? If you know, it's like you can't say everything first. See what I'm saying? Got to make a decision what we say first. And I think, you know, what we say last has some punch as well. So we got to make a choice. Okay. This is surely not the only stuff that we should refer to from geometric scene here. Surely geometric assertion belongs here, among other things.
Yeah, definitely geometric assertion.
I would have thought graphics should be here as well. Anything else?
Maybe tab view, probably not though.
No.
No.
Definitely not. Now, I wonder whether we should point things like circle to geometric scene?
I do currently.
Oh, wait a minute. So you've put that in circle?
Yeah, you asked for that last time.
Okay, fine.
There's a line at the bottom of the details that says circle can be used with symbolic points and quantities, and then...
Okay, great. And it points it down here, right?
Yep.
Magnificent. That's great. That's exactly what we want. Okay, that was a bit more time consuming than I expected. So we've now got these other ones, find geometric conjectures, and did we do random instance? Let's look at random instance again. Well, it is what it is there. I think that's, yeah, okay. Okay, I don't think that's terrible. Okay, let's go, well, let's see. Should we look at geometric assertion? Is that going to be easier?
I don't think any of these are going to be easy.
No.
Lovely. Magnificent. Represents the assertion that all the objects satisfy prop, right?
No, because prop might be a relation between the obi.
Why is that giving a spell check error there? You know, I've seen these lingering spell checks a bunch recently.
Me too. I think there's a 64-bit front-end thing.
One of the bits got left over. Okay, Andrea, can you report that, please?
Yes, I just took a screenshot of that.
I mean, I don't think it's a little hard to reproduce, but I think they need to figure out, you know, yeah.
Yeah, because actually
go ahead.
Before it doesn't reproduce. It's just, yeah. I just took a screenshot and I'm going to send it.
Okay. I think it goes away afterward.
Well, okay. They need to go hunt for this. I have to say, the 64-bit front end has been, I've forgotten that it was 64-bit. It's surprisingly stable. Okay, all right. Okay. What do you mean points or regions? They can be all kinds of stuff.
Those are the two kinds of things they can be.
Yeah, what other things are there?
Well, can be points or regions specified. I mean, they can be, you know, perpendicular bisector of a this over that. Is a perpendicular bisector really a region? I don't think so.
It's an infinite line.
Infinite line.
Yes, I know that, but it's very confusing to people because they'll think region means a region object. I don't think we should put this in here. I think this is not relevant. I think we don't need that line. I think that line only confuses things. Let's put this down at the bottom. Okay. Points form a clockwise polygon. Is that fair?
No,
Yeah.
you use that on a polygon.
Oh, okay.
You can actually use that same string on either a polygon or on a list of points, which is why it's also under relations as well as predicates.
Okay. A polygon has the points in a polygon are clockwise, go in clockwise order.
Yep.
A polygon is convex.
You mean the vertex point, not the point in the polygon?
All right.
Yeah.
The vertices of a polygon.
Mm-hmm.
Okay. What is this one?
A polygon is cyclic.
What's that? What does that mean?
The vertices lie in a circle.
Oh, wow. I never would have figured that out. The vertices polygon lie on a circle. Okay.
Why?
The angles in a sorry?
What's wrong with a polygon is cyclic?
Well, I didn't know what that meant.
Well, if you don't know what convex means, you won't know what a polygon is convex means.
Yeah, but more people know that. I'm using myself as a test.
Yeah.
I don't know what a cyclic polygon is.
High school geometry students can be more likely to know cyclic than convex.
Okay, but people know the word convex as a piece of everyday,
Right.
you know. Well, they either, if they don't know what it, you know, defining convex is more complicated than.
No, just to say, we cannot rephrase convex easily.
The angles in a polygon are equal.
Vertex angles or interior angles.
Are all equal. The side lengths in a polygon are all equal.
I'd say of a polygon, yeah.
Okay. A polygon
Is equiangular and like equilateral.
Is regular. Just say it's regular.
Okay, well, I don't even know. A polygon is simple. What does that mean?
Its sides are non-self-intersecting. So we already, inside of geometric scene, when you just use polygon without this, it already assumes that it's simple. So I'm not sure we should list it here.
Okay, let's futurize it here. Okay, for polygons or lists of points.
No, none of these are for lists of points.
Okay, the following predicates for polygons can be used. Is that right?
Yeah.
Yeah, they're all polygons. Yeah.
You know, we don't even then need to say, oh, well, polygon. The vertices are in clockwise order. The polygon is convex. The vertices are in counterclockwise order. The vertices lie on a circle. The interior angles are all equal.
Much better.
You're missing a space on equiangular to the right. Angles are, there we go.
Okay. The following relations between points can be used. Okay, what does this mean?
The points are in clockwise order.
Well, so it means that if you
Relative to the origin or what?
no, if you draw line segments between neighboring points, it forms the boundary of a simple polygon whose vertices are in clockwise order.
Points are in clockwise order if joined. That's a pretty obscure one.
Successively joined.
Okay, points lie on a line.
Right.
Should this be the points?
Yep.
Also for the one above?
Okay, does this mean that they lie on a circle?
No, this means this means that they're either clockwise or counterclockwise.
I see. Well, the points don't double back. Is that what it means?
Well, they don't necessarily have to double back for this to be for it to not be cyclically ordered.
Yeah, I think what you're doing is right.
Yeah.
What's this one?
You form successive angles between the pairs of points with the vertex at PT.
Okay.
And then all those angles are equal.
Okay. Successive angles
at the vertex PT or something like that. It's used for like trisecting and insecting angles. Like if you want to say that.
I understand. Well, how about this? Subtended at PT are equal. Is that right?
Yeah, I think so.
Okay. This has been futurized, anti-parallel.
I have it like that because the most recent time I looked, anti-parallel wasn't working, but we'll fix that.
Okay.
I think it's.
You may already have it fixed.
Yeah, I have it fixed.
Okay, so between lines and other regions, I mean, these are mostly. Okay.
Sure.
What does similar lines mean? What would that even mean?
So all finite lines are similar. Lines of the same length are congruent.
I see. Between lines and other regions can be used.
So that makes it seem like one of the parts of the relation has to be a line.
Okay, but you can't say regions here. Most people aren't going to get what this means.
Lines, circles.
Okay, lines, circles.
Makes it maybe clearer.
Okay.
Just say geometric
that reads better.
objects.
And also the back measurable subset of R2.
Okay. Okay. So what does parallel mean if you say it about triangles?
Has no meaning.
Okay. So maybe we should break this table into ones that are about lines and ones that are about more general things.
Okay. Some will be in multiple of them.
Which ones will be in multiple?
Well, so
Congruent could work for anything.
What's that? Say it again.
Congruent.
I don't care. That
Could work
we
for
can
anything.
say it about figures, because the fact that there's a special case that congruent works for lines is amusing but not too relevant, is it? Or do people?
right, no, it's you're well, congruent circles. If you sometimes they'll
Well,
say
that's fine. Congruent circles is fine. I mean, we would
Right.
say the. Okay. Following relations between lines can be used.
right.
The following relations between between geometric objects can be used. Which, by the way, actually says the right thing now, because it's actually somebody is making very funky noises there. Okay, lines are anti-parallel. Well, just anti-parallel. Lines are anti-parallel. Lines are
The lines.
What's that?
The lines.
I would say parallel and in opposite directions.
Okay. But in opposite directions.
Right.
Lines are concurrent or on top of each other.
Well, no, they meet in a common point.
Oh, well, there. So I didn't know what I was talking about. Lines.
Use the word intersect.
Okay.
Lines intersect at a common point. We got feedback from a WTC attendee that they had trouble finding that.
Well, maybe it's the wrong name. Concurrent.
Concurrence.
Well, I mean, we can have a thing
the
called
standard
intersect.
terminology.
Okay. Okay. Lines intersect at the point PT, is that right?
Correct.
Yep.
Okay. We've got something that sounds distinctly like, ocean. Background noise. Okay. Congruent doesn't go here, right?
Correct.
Matching parallel, what does that mean?
Lines are parallel in the same direction.
What the heck does that mean then?
They're just parallel with no reference to the direction.
Is that standard usage?
For
In
parallel and
context,
anti-parallel, yes, we introduced matching parallel because there's no pre-existing term.
the convention is people use parallel to mean matching parallel in cases where they care about that.
Right. So a lot of times they say parallel and they're leaving out a hypothesis.
Lines are parallel with any direction, with any orientation.
Yeah. Relative.
With any relative orientation.
Yeah.
Okay, pairwise tangent. That's not
Doesn't
for
go here.
lines. Yeah. Lines are perpendicular. Mutually tangent doesn't go here, right?
Nope. Neither of those.
I think all of these should be the lines.
To be symmetric with earlier sections, yes.
All right. Okay, you can fill in the rest.
I'll do that.
Okay. Okay. Okay, pairwise tangent, what does that mean?
That means that each
Each
pair
pair
of
of them are
objects, each pair of objects is tangent to each other, but it could be at different points for different pairs.
3 points. 3 circles is the canonical example.
Yeah.
The objects are tangent to each other in pairs.
Yes.
Okay. What does mutually tangent mean?
So they're all tangent at the same point.
Are all tangent at a point.
Yeah. At a common point, maybe.
Yeah, at a common point.
Okay. Okay. Aren't there a lot of other assertions here? Aren't there a lot of other Q functions that we want to say that are here? I mean, like region member. What's that?
We do support region member, but
We could add a bunch of Q functions, but
well,
but I mean, they're not. I'm not suggesting they're supported in geometric scene.
Right.
That's not the claim here. The claim here is, how do you tell? So if I say geometric assertion,
right, it only works inside of geometric scene.
I think what you're looking for will be find geometric proof in the next version.
But what if I just want to find out if it's true? I mean, I might want to find out if it's true about concrete objects.
Mm-hmm.
But because we didn't want to do this, this was part why we introduced this geometric assertion, which more emphasizes the stating.
Right.
I understand that, but we might want another function that just does it.
Well, I think if there's another function that does it, we might just keep. I mean, I'm not sure we need another function. I think the idea was.
Yeah, if it's concrete, it would just do it.
Yeah.
I think we should make that happen. I think this seems quite useful.
This was for you.
Yeah.
Is Charles still with us?
Yeah.
I'm here.
Okay, we would like this to actually evaluate.
For all the possible predicates, I mean, we have convex polygon. It's a more matter of design how now, which direction we are going. If we want to geometric assertion to evaluate for concrete region Q object like that, we can work on it. But it depends how far we want to go on the current design.
I'm sorry, I spaced for a second. Say it again.
So currently we introduce like convex polygon Q does those checking. Right? So do we want also to support to implement geometric assertion for all these predicates? do we want to support, symbolic parameter? There's that whole build-up we need to discuss separately if you want that.
I don't know whether we want symbolic parameters. That seems complicated. I mean, I think ultimately we might want that, but I mean, these are just, look, these things. Sorry, you have a convex polygon Q, is that correct?
Yes.
Oh boy. So if I say convex polygon interesting. So if I put an A in here, why does it say that?
Well,
you can't make
Click
concave
introduce it.
triangles.
yeah.
I'm sorry?
You can't make concave triangles.
Okay.
Just do AB.
But well, in principle, it should give false. That's a bug because the A can overlapping. It should be on the constant region.
Well, I think
It should always give false when the region is not constant.
Okay, but this doesn't give symbolic. I mean, it will be super interesting to be able
It's
to give
a Q
the symbolic
function.
condition.
Cannot give symbolic.
Right. So I agree that geometric assertion would be magnificent if it gave, symbolic, if it translated this to a symbolic form.
I guess.
Okay, so listen, this should certainly refer to things like convex polygon Q. What else should it refer to of that type?
Do we have a similar Q, Charles, or congruent?
No, we just have convex polygon Q.
Okay, well, what about things being on other things?
We have
Things being
simple polygon Q, but we didn't want simple.
We have simple polygon Q.
Yes, but I said we didn't. I said we have simple polygon Q, but we didn't want simple in the list here. We removed it. That's why I'm.
Yeah, right. So I don't think we should do that. I think we should say, well, we could have it at the end. I mean, checking that a point is on a line is like reduce or something, isn't it?
It's region member.
Okay. Okay.
Should we have regular polygon?
No, because it's a constructor,
Okay.
not a queuer. All right. Now we've got
So I was just thinking.
this is way too many examples of the same thing. I mean, wait a minute. What was that there? Relationals. Oh, you haven't even got basic examples. You need to add basic examples here.
We'll get to examples.
Okay. All right. So now up here, now we're going to go psi, triangle center. I'm hoping this is fairly straightforward, he says, famous last words. To the center of the specified of the triangle tri.
Over 4, either one.
Let's use 4 then. Following center types can be used. Let me go in. I think we went through this before.
I know we haven't because you've never been able to update it.
Right. We went through some of triangle construct, and this is basically a subset of triangle construct.
Okay, let me look then.
I think we've gone through some of triangle construct. Maybe not.
No, I don't think so.
Oh boy. Okay, and the other thing we've got, my gosh, let's just look at triangle measurement. Okay, and then we've got find geometric conjectures. Oh, who said this was going to be like super simple and short?
I think I may have said that sarcastically once.
Okay, fine. Let's look at this before we go back. I mean, the triangle center stuff is going to be straightforward, I think, if time consuming. Let's take a look at this. Okay, so it doesn't actually find those conjectures. It reinserts them into the scene, right?
Correct.
Correct.
Oh boy, how to say that?
Just put it in the details.
All right, but if I say this, so if I take this guy here.
I won't find any for just a triangle.
Didn't it have a triangle that was forced to have an angle of something? Okay, here. I'm going to put something in here. I'm going to say planar angle. See if I know what I'm doing. Planar angle of ABC equals pi over 2. Magnificent. Find geometric. Okay, I don't even understand what it would have done. Okay, so let's put a thing here, and let's.
It may have done something.
Yeah. Put
circle.
Yeah.
Circle
yeah. I think it did do. It should return that the other angles are 45 degrees.
Okay, well,
no, it wouldn't, because that's not necessarily true. Never mind. You would.
Okay, so what the heck am I doing here? How does it? It should have some indication.
That's what we were saying earlier. This should be a tab view that code isn't merged yet.
Yeah. Locally, this would be a tab view.
Can you show that to me?
You want me to share my screen?
Yeah, if you can, or you can just send me a notebook that has it in.
Let me share my screen probably, so you don't have to load.
Maybe we should give a message when we don't find any.
Right.
Definitely.
You'd have to stop sharing your screen.
I know.
Okay, there you go.
Go ahead.
Share. Let's see. What am I looking for? Let's go with.
Sorry, unfortunately, I will have to leave. So.
Okay. All right, Charles. Well, you can always watch the archive of this.
There we go.
Okay, I will.
Viewing pleasure, and hopefully somebody will take notes if you need to be aware of things.
Thanks.
Okay. See you, Charles.
See you.
Let's see. Yeah, there we go. So that's with style. Let's see, and down here, find geometric conjectures.
No, I don't want to see the input form. Get rid of the input form. I'm not interested in the input form.
Okay. Right. So
I don't understand any of this. Get rid of the formatting, because otherwise the formatting is going to confuse us.
This. Okay, let's just kind of. So we're just looking at this find geometric conjectures of Thales pick 1. So
yeah, I understand. But show me Thales pick 1. Show me what Thales pick 1 is. Okay, so that's what I was saying. Get rid of the red.
Remove the red. That's what Steve meant.
Oh, sorry. Yeah, we'll.
Yeah, and get rid of that input form. I don't understand the input form thing you say there. What are you doing?
But if you want to know what's really inside, you need the input form.
Yeah, I understand. So I see. You're doing the crazy thing of putting multiple stuff on a single input line. I hate that.
This is his testing notebook.
Yeah,
I understand. This is not intended for prime time viewing.
This should just be
O equals.
Yep.
O. That's not an O. That's a parenthesis.
Oh wait,
that's a 0. It should be an O.
Yeah. Okay. So get rid of the input form.
Okay. Why is that red? Oh.
That's all right. Forgot this guy.
That's the red still.
Yeah.
Okay. Get rid of the extra.
There we go.
Okay, fine. Okay, now say find on that. All right, go back up there.
Oh, I see.
Say find geometric
conjectures of
that %181 or whatever it is.
Right. So
okay, I don't understand this. Okay, so it is using some color that it picks out of somewhere.
Right. So it's highlighting the conjecture. So here it's saying these two lines are perpendicular, so these two lines get highlighted. If you say that this angle is 90 degrees, which is equivalent, it shows it.
No, but does it? Okay. All right. Okay. Wait a minute. Okay. So listen. Let's talk about the graphic design of this. I mean, like planar angle ABC. Obviously, there's a traditional form there that has an angle thing. Could whoever's making the background?
Oh, sorry. There's that's
no problem.
Me.
Okay. So this is some weird tab view with a side tab. Okay, and what's happened there? So the thing I'm trying to understand: how complicated do these get? What happens if those things get really complicated? The conjectures.
The conjectures, I mean, we make them, we know them. So right now, at least we don't search for one that are ridiculously complicated.
Right. Okay. So Lynn had the option that I currently don't have activated of some sort of plain text to the side that would hopefully cut down on the size, but it's a little weird, and I don't think we should use
but
it.
This was also one of the reasons we looked earlier. There was the method option where we can specify the tab view option in case we wanted.
That's true.
Okay. I mean, this thing. Okay, so what happens if I just want the plain Jane diagram without the conjectures? I can't get it. And after I found the geometric conjectures, presumably there's a thing here which will get me back the unconjecturated form. What's the property that just gets me back the original instance without the conjectures?
I don't think we have one currently.
Right, I think it'll always have the conjectures with it.
But it would be trivial to add a new string version that just cleans it off.
Yeah,
true. Yeah, that would.
I think we should do that.
Okay.
What should we call it?
Conjecture-free scene, or conjecture-free geometric, or conjecture-free geometric scene.
That's very complicated.
Okay.
And also, we always refer to it.
It's a string argument, so it cannot be delete conjectures.
No, I understand that, but I'm just saying something like scene might be the, well, you're saying conjecture.
It should be conclusion, not conjecture. We have formally always refer to them as conclusions, not conjectures.
Then we need actually a few. You might want the one that basically is totally cleaned off, what we called earlier the abstract scene, and we want the instances.
Yes. Yes, that's a good one. Abstract scene and then scene instance. Those both.
We have instances already, right?
Right. We have instances,
Yeah.
but that's for multiple. This means something else. So is it abstract scene? And did we say scene instance or
I would
just?
think so. Yeah, I would think scene instance is the right thing.
Okay.
How is scene instance different from instances?
Well, scene instance strips away the conjecture.
It's not totally obvious from the name.
Yeah, it's not
That's
obvious.
crazy.
Yeah. I don't think it's quite right.
I think we just need one more for abstract scene.
What do you mean one more? Oh,
Just, I only see the need for one more sub option or sub value.
so you're saying instances should
How
always
do you get the
strip
instances
conclusion?
without the conclusions?
That's what we're saying, yeah. But it gets just the instances. But see, look, there's two different things. If there are multiple instances, look, there's
Exactly.
different cases, right?
Exactly.
It's
That's
different
not it.
cases. Hey, practical point. Are we going to continue for a while, or should we wrap up and continue at a different time?
I would love to wrap up.
Yeah.
All right. I think that could you give me back my screen here?
Oh, sure.
So we're going to have to continue this probably if we can.
Tomorrow?
I think we should try for tomorrow is really busy. Well, let's see what can be done for tomorrow.
I'll find Alex.
Yeah, I think Michael, when are you taking off for?
I am still available tomorrow and Monday.
Okay. I'm a little concerned here. Okay, so I'm not too concerned about the triangle centers. I don't think we're going to have anything terribly horrifying there. This fine geometric conjecture looks a bit iffy to me. I mean, you're saying it is the main event here. So, that's okay, all right, let's try to continue, even if briefly, tomorrow. Okay, I'm going to push all these results back into the repository. Great. Okay, beautiful functionality. Talk to you all soon.
All right.
Thanks.
Okay, see ya. Bye. Thanks.
Bye.